So we're going to go over to Hunter now at JKI. He's going to show us a little bit just kind of give us an update on the work he's been doing. He presented at our last meeting about JCrawler, which was a tool that he's been developing to do kind of a more thorough static analysis. We just saw kind of a free version, and what we're going to find with that free version and what Tim's going to run into is that maintaining that and keeping up to date with all of the security vulnerabilities that you have to really do a thorough analysis on is a really big deal. And so JKI is kind of taking that on in a more direct role with this more thorough tool. And so I want to just get an update from him. So I asked him to come in and do that.
Great, thanks, Steve. Yeah, and I'm certainly impressed with a lot of Tim's tools. I know I'm going to be anxious to play with some of those. So thanks for sharing that. So I wanted to talk about Crawler. Some of you have heard about this, so I have a few updates. And today I'm going to focus a little bit on the deliverables that we try to get through this process, because in the end, that's what the requirements or a lot of these things driving us towards it are for. So let me start off with an introduction. I'm Hunter Smith. I'm a staff software engineer at JKI. I started my career at NI working through applications engineering on K-12 engineering with things like FIRST Robotics and Lego Mindstorms. I did a little bit of YouTube engineering for a minute. And then I spent 7 years at SpaceX working on their rocket engine test stands and Stage 0 teams. You may have seen Stage 0 for Starship do some pretty amazing things this last week. But for the last 3 years, I've been at JKI, where I've had the opportunity to work on a lot of different projects and have really been diving into security on a lot of them. So many of you probably know JKI through VI Package Manager, or you may know our legendary CEO, Jim Kring. But not everyone realizes that JKI has been around for more than 20 years, working in a variety of applications, from fusion energy to medical devices and leading optical test systems for semiconductor, but more and more we've been doing aerospace projects. For the last 2 years, I've been working on our JKI Stargode product. This is a turnkey rocket engine test stand software that we've customized and are deploying to NASA's ArcJet. This is a facility that does, it's a hot wind tunnel, more or less, that uses basically lightning in a tube to superheat some plasma so that you can test pieces of heat shield or components for aircraft meant to do reentry or high velocity flight. Through this process, we've gotten to learn a lot about the documentation and requirements when you're working for one of these agencies. Now, here in the US, if you're writing code for one of these agencies, it comes with some extra requirements and some extra paperwork. And it sounds like a lot of the things that have been discussed today, the other requirements for the EU, are also driving in a lot of these same directions. So how do we kind of get a hold of our security requirements? And sometimes it requires making a big list. For NASA in particular, we had to work with a document called NPR 7150.2c that defines a software engineering handbook that then links to safety and security standards, policy directives, configuration management, and then links out to common weakness enumerations. And I'm sure some of you have had the experience of diving into these 3-letter acronym agencies' requirements and finding yourself with your head spinning. And this really is simplified for readability. I could have accurately made it a lot more complex. And so it sounds like, all of us in this room have different boxes that we need to check based on software engineering. And this is not the Society of Women Engineers. That's a great organization, but this is talking about the NASA Software Engineering Handbook, the common weakness enumerations, the CVEs that we talked a lot about earlier in relation to bombs, and then, as we've been mentioning, the NIST and CRA requirements. For this NASA project, SWE was one of our main driving requirements, and this is one of the SWE requirements we had to adhere to, SWE 207. The project manager shall identify, record, and implement secure coding practices. And often when going through this documentation, you find these honestly hand-wavy, unhelpfully vague sentences. And so if I'm given that and I'm required to deliver some paperwork or some documentation to someone to prove that I've done this, it can be a real challenge. How do I scope this? How do I do that systematically? I don't want it to take too long. I want it to be efficient about it. I want it to actually be useful, but in the end, I still need this deliverable to turn in. Now, if we kind of work backwards, so one of the things we wanted to do is how are we going to implement a lot of these secure policies? So we were required to create a software development plan that identified the 81 software engineering requirements and the 28 common weakness enumerations, and create a large document that specified exactly how we identify, track, and maintain these. And all the highlighted things here that you see are all areas that are impacted by security. It ends up being a big part of the document, a big part of the work. So what are the deliverables that we actually turn in? You know, we saw that vague sentence. How do I prove to someone, hand something in to my customer that checks that box? It can be especially challenging when the person checking that box may not be a LabVIEW expert. They may not know anything about LabVIEW, and so they'll ask, you know, how many lines of code do you have? And you're like, well, let me tell you about that. So when we try to create these deliverables, it takes a lot of explaining, and so the deliverables that we look at are actually, you know, reports, assessment, reviews, audits, metrics. These are mostly prose. These are not necessarily hard numbers. They're not necessarily empirical. These are subjective, they're open-ended, they're ongoing, and they're self-defined. It's up to me as the project manager to take that SWE requirement and that incredibly vague sentence and build a story so that I can convince my customer and then convince myself that I can do this honestly and deliver something very secure. So in the end, we want to create something that does check the safety requirements. It meets the requirement, it makes sure my customer's happy, it makes sure I'm not in breach of contract. It is important that everything we say in there is accurate and correct. And so I have talked to some customers recently who were working on a project that had been around for a long time and had a lot of history with a government agency, and they were asked to apply new security standards and were able to, by declaration, say everything pre-existing this date is therefore secure. And I said, wow, I'm jealous of that. That didn't work for our new project. But just like it's up to every project manager to interpret those requirements, it's also up to that agency to interpret that. And so just because one NASA agency or one NASA site will approve a plan doesn't mean it works for something else. It is dependent on the requirements and the safety and the security that you need to operate in. So to satisfy a lot of these, we created our JCrawler static analysis tool. So just briefly what this tool is, this is a way to automatically check every VI and every file in your repo and check mistakes. I will say by far the most useful check is just that a VI is not broken. On every commit, I can have my automated continuous integration system in my repo run through every VI in the repo and make sure nothing is broken. And that makes, I didn't rename a type def or delete a dependency or break an API for some part of the code that I didn't have loaded or wasn't working on. That's by far one of the most useful tests day in and day out. But we can also enforce standards, audit style, and be able to create reports. So some of you may have used VI Analyzer before. One of the limitations with VI Analyzer is that it only works on VIs. We created Crawler to work with all common LabVIEW types and any file. You can actually run checks on any file by path, so even things like text files, if you want to make sure you don't have passwords saved in there, you can. We also worked hard on the reporting side, because as I mentioned, it's one thing to have a big pile of data. It's another thing to be able to boil that down into something that I can express as a narrative. And so we can create XML reports and CSV reports, as well as rich console output that's visible when it's running in an automated way. We wanted to make it very easy to use. So Crawler can run as a CI tool, or it can run in a user interface. Here I'm pointing it to a small library. It can identify some things. And in this case, with some of the rules, it can actually automatically fix them. So for instance, if I forgot to separate my compiled code, that's something very easy to correct. And this ties in a lot to what Tim was saying, where if you can identify everywhere where you're using an OS command and delete a constant or say, hey, you're not allowed to use this VI, these rules can be easy to integrate. I'm gonna just let you guys watch this for a minute. How many of you are having a little bit of anxiety and heartburn based on this? I know a lot of you have encountered this where you go to open a project, especially in a shared repo, or maybe you have to dust off something that hasn't been used in a while and you get stuck on this loading. So that's why, as I mentioned, the broken VI rule is so important. And so we have some rules that are designed to make sure that the structure is correct, that it's not broken. The live hierarchy rule verifies that all class members are nested under their class in the directory structure. We have rules that gather metrics so that I can do statistical reports on my code and understand, the code complexity and size on disk of each. We can verify properties for a project I'm working on. It's required that all VIs have separated compiled code, and we can even check style. Just so you can see, this is what a rule looks like. Crawler supports user-created plugin rules, and it's as easy as you get a VI with an already open VI reference. You can then use scripting to measure any properties, check any metrics, and then create what we call rule results. Rule results can be invalid, passed, skipped, failed, errored, or info. In this case, these are just two metrics, and so they're just the info type. And then Crawler does the rest. Crawler does the rest to aggregate those, to create reports, to create tools so that you can then apply this holistically to your code. And if that make changes Boolean is true, the rule can even then use scripting to make proactive changes. We then take Crawler and stick it into CI so that now on every single commit, we're going to run it. I really like the report at the top. That was something I built in early on, so it'll tell me exactly how many VIs and controls and CSVs and XML files I have. That kind of tells me the shape of the repo. And then in this case, it's going to tell me all 22,000 of my results ran and the rule, by results. And then I get this in my email and I get a very clear list of, hey, these VIs are misplaced. Or that debugging was accidentally left on when it should have been disabled. Crawler can also export that CSV report. So now we have that same data in a very easy to use spreadsheet. And so it makes it easy to identify, where we may have left some to-dos in the code or where we may have, where concentrations of code complexity are. So that's kind of what Crawler does in general. But now let's zoom in a little bit and talk more about security. So as I mentioned, for this NASA project, we were assigned a specific list of 28 of these common weakness enumerations. They cover a lot of different areas, some that are intrinsically safe in LabVIEW. So for instance, a lot of these have to do with memory management and allocating and deallocating and out of bounds memory. So for instance, this one down here at the bottom, the CWE 787, the out of bounds write. Now, if we're using LabVIEW and it's a memory managed, then we can place all that burden back on Steve and say that, NI is going to manage that for me so that me as an individual developer, I don't have to do that. There was a question, does Crawler work on Linux? I haven't tested it, but it should. It does not have any specific Windows requirements, but I haven't done that yet, but I may try it later. Reach out and let's do an experiment. So I want to highlight one of these CWEs in particular, and this is 78, improper neutralization of special elements. Now, in other languages, there's lots of ways to do command injection, where if a user types in a prompt, I can do something nefarious. There's this classic example where someone put a drop table on their license plate in hopes of breaking the automated CRM system that's managing those. In LabVIEW, there's not a lot of ways to do OS command injection, again, because LabVIEW rules are a little different, but there's definitely one. And this ties into exactly what Tim was saying, where I want to be able to go through in my code and identify everywhere where I'm using a sysexec, because from that tool, I have the power to delete files, modify privileges, move stuff around, and depending on the privilege of the application running it, be able to cause a lot of havoc. The best way to protect against OS injection is that your commands are hard-coded. So this is an example function where we were trying to measure we were trying to find the process ID for a task by name. Originally, we had it where we would use a format into string to create that command and identify the specific task. But then because of the security rule, we refactored it where the command is a hard-coded constant. Then we use some string parsing to then pull out the tasks that we care about and get the same data. This does mean it takes a little longer because we're now asking for more data, but that was a trade-off that we decided to make. So how can we use Crawler and how can we use our organization to address all of these different security checklists? So one of the things we did is we took those 28 CWEs and grouped them into a couple different checklists. So checklist around sensitive data, network communication, file I/O, operating system commands, authentication, and low-level memory management. In particular, I want to highlight the OS command security. And so first, we need to be able to group the rules. So now we've done that. We have all of the security rules related to OS commands. Next, we need to be able to flag them. And so the indication in that list says any VI that uses sysexec, DLLs, or batch files, or generated batch files is applicable to this rule. And then finally, we need to do checks. And so this is a little bit of a manual process in some cases, and a little bit of an automated process in others. We can certainly look at sysexecs and see which ones have string constants, but there are a lot of exceptions. And so usually by flagging them, that allows us to audit them in a focused way that doesn't require us to manually dig through thousands of VIs in a large repo. We took those 28 CWEs and we just talked about how some of them were addressed by security checklists. Some are addressed by LabVIEW caveats by just saying LabVIEW operates in a different way. The way it handles memory is different. The way it handles user interface or build applications is different. And then some are addressed through developer standards. And so, for instance, how do you prove that you have no infinite loops? That one can be fairly tricky. And so you say, well, we make sure that we don't have constants wired to the loops, and through our peer review process, we verify that every loop has a safe exit condition and a backup exit condition if things go wrong. So how are we going to use, for the security checklist, we need to be able to tag them. The LabVIEW caveats and developer standards we can apply with a pretty big blanket, but the security checklist, we need to be able to go through and identify these. So what I did was I created a custom crawler rule that tagged VIs. Now this table is a little small, I apologize, but across the top you can see I have my SCL 2, 3, and these are my 6 security checklists. And for each checklist, I define a list of VIs that is applicable. And so for instance, on the OS command, any use of the DLL function or the sysexec gets flagged and is matched. Towards the right, you can see I have more and more granular rules where now within the security list 3 file IO list, I want to find every use of the close file primitive, or the delete file primitive. And this gave us the ability to now identify all the VIs by security checklists. So now instead of 5,000 VIs I need to audit, I have a list of 40 VIs I need to audit for file IO rules. One of the ways we do this is by addressing things with wrappers. And again, this kind of ties in with what Tim was saying. If I say, hey, no one is allowed to use the TCP write function by itself in our repo. Instead, you have to use the TCP write safe function that includes some check or some error handling or some particular sanitization that's required. And now I can have a crawler rule that will fail if you call the TCP raw. And through my tagging system, I can identify all the uses of either the primitive function that's not allowed, as well as the wrap function that is. Now, combined with crawler and this custom rules that are able to tag individual VIs and create a massive report of every VI in my repo, we're also using some of the newer features of JKI Dragon. So JKI Dragon is included in LabVIEW 2023 and later as part of the product. At the bottom, just next to your dependencies, you also now get a package dependencies list. This will go through all the files in your project and identify which packages are called. And then from the right-click menu, you can actually go then identify the callers of that package. Now, I did ask Jim to give me a little bit of extra access, and he turned on some internal features of Dragon that we want to find ways to roll out that allowed me to automatically pull that list for my entire repo. And so now not only did I have a list of all the primitives that were called, but now I can identify out of the 15 packages we're using, only these 3 VIs in this package are used in only these 5 places. And that gives me a lot of ability to audit and examine it. So we now have a lot of different sources of truth. We have the developer knowledge. I work on this repo every day. That is inherently part of the information. I kind of know where some of the skeletons are buried, and I know what things we're using. I'm going to use jcrawler to use my rules and tags to help sort things. I'm going to use Dragon to help identify packages. I might use tools like SBOM that were already discussed. And I also want to combine my unit test code coverage. And in the end, what am I creating from that? It's prose. So although it's been very technical and all of these things I need to now tell a story, and it has to be prose that is signable. So now I need to find a way to boil all these things down and, in an honest way, but in a concise way, tell that. But these tools that we've created now make this easy where, an intelligent developer can use these to create it. So the reason we created all of these tools was for our Stargoat product. So this is our turnkey rocket engine test stand. And just to give you a little peek, this is what our daily pipeline looks like. And so on every single commit, we're going to do our static analysis to verify all of our properties. We're going to check our unit tests. We have our test integration engine, which is now running full subsystem integration tests. And we're going to automatically build all of our executables. Now, one of the reports from this, so now I have unit test results, static analysis, crawler reports, build automation reports, and I've just created a tool that is our aggregator. So this creates a massive spreadsheet. You can see the X column over there is in the thousands of every VI in my repo. All of the tabs on the left are from crawler. So crawler is able to identify which code is separated, where my JKI state machines are, the size on disk of every file, but then I'm also able to combine it in my unit test coverage. And using this, we were able to identify, VIs that were called that shouldn't have been, or VIs that didn't have coverage. And then I can have that nuanced discussion and create that nuanced prose. So JKI works with a lot of customers. This is something we've been doing a ton of recently, where we sit down and coach and develop tools and systems to create specific deliverables. A lot of times we structure these not as just a simple license, but as around a deliverable. We want to help you all the way to the finish line so you can get that security report. We have our products where we've now bundled up the tester, crawler, and builder into our engineering suite. Many of you are familiar with VIPM Pro, and we've had customers license portions of our software development plan if they happen to need a NASA specific one. All right, I'm going to pivot a little bit now and talk about AI. We have some new tools coming out from JKI that will be available very soon, and we want to get you guys hands on them. So I want you to meet Jake. Jake is our AI expert assistant. This is something that Jim Kring and Steve Balls have been working on vigorously for months. Some of you may have seen the AI webinars they've been doing, where they've been diving into a lot of the technology behind this. But they've now released an internal build, and I'm starting to use Jake a lot. So Jake is powered by ChatGPT's AI technology, but it's been specifically trained on LabVIEW. It can do things like search VIPM. And it's broken the large language model LabVIEW barrier. So through when you're running it locally on your system, it can access the code you're working on. And so you can ask it questions about your code. This is a new product. The capabilities at first, some of the things you can see listed here are things it can do, but this is something that's going to continue to grow. The first version of Jake will be available in about 2 weeks. And so if you're, please check out jki.net/AI if you want to learn more, or find us on LinkedIn, and we'd love to share. Here's an example of some of the questions I've asked it, and including one this morning, what security vulnerabilities should I be aware of when using a sysexec VI? And you can see command injection and malicious commands are right there at the top. The version on the left is the desktop app, and I asked it a question. LabVIEW does not document the slash codes of all the different carriage returns, and so it was able to correctly identify the /n, /r, and /rn. That normally I have to create a little manual VI, and so I'm actually already using this and excited about it. So Jake will be out in about 2 weeks, but today we are sharing the LabVIEW error helper. So this is available right now. If you go to JKI's website, you can type in an error code. Again, it has a backend that's been specifically trained on the entire LabVIEW error code database, but it's also going to search the web. It's also going to search BIPM. It's also going to search in i.com forums and aggregate a lot of info. And so if you've ever been cryptically searching, NI's website search is legendarily tricky sometimes. This can be a really great tool, and this is available now for anyone if you want to start poking around. If any of you are curious or have questions about static analysis or security or AI, please reach out to myself or Tariq. He's in the call. He's our technical accounts manager, and he can help make things happen. Yeah, does anyone have any questions before I hand it back to Steve?
I will say that AI series, the webinar series, I went through and listened to them. There were 4 last time I looked. Maybe there's 5 now of those sessions, and they're each like an hour long. Very in depth, very technical. So if you don't know anything about AI, it's a great starting point, because if you don't know anything about AI, like me at the beginning of this, I was like, well, you use AI to what? Generate LabVIEW code, and there's so many other ways to use it and leverage it and to understand what that even means. And they go through that in great detail. So it's a really great webinar series. So thanks.
Great. Thanks, Steve.
Hey, Hunter.